Assalamualaikum and a very good afternoon everyone. Thank you for listening to my talk. My name is Dr. Nur Hasyareeda Hassan from Universiti Kebangsaan Malaysia, UKM Bangi. Today I would like to share my research entitled Synthesis of Protic Ionic Liquids, Triethylammonium Hydrogen Sulphate and Sugar-Based Deep Eutectic Solvents. Before we go further, let me give some general introductions and important facts about PILs, or Protic Ionic Liquids, and DAS, or Deep Eutectic Solvents. Ionic liquids in general are salts that exist in a liquid form below 100 degrees C. Protic Ionic liquids are a type of ionic liquid that is formed via proton transfer from a bronzed acid to a bronzed base. Meanwhile, DAS is a mixture of two naturally occurring components, namely hydrogen bond acceptor, HBA, such as quaternary ammonium halide salts, phosphonium halide salts, and metal chloride and hydrogen bond donor, HBD, such as carboxylic acid, alcohols, amides, carbohydrates, and metal chloride, which associated to each other through hydrogen bond interaction. Both solvents display a wide range of unique properties such as high thermal stability, non-flammability, insignificant vapor pressure, and low chemical reactivity beside their fine-tunable density, viscosity, polarity, and miscibility with other common solvents. For that reason, the usage of selected iols and DAS to aid the phytochemical extraction process is considered as a great choice in increasing a significant amount of bioactive constituents, while at the same time reducing the use of toxic and volatile organic solvents for a greener environment. THS is a low-cost protic ionic liquid resulted from acid-base reaction of sulfuric acid and triethylammonium at equimolar ratio at 60 degrees to 70 degrees, resulting in a white crystalline protic ionic liquid. Okay, this is how we synthesize our triethylammonium hydrogen sulfate based on just acid-base reaction. Meanwhile, for sugar-based ionic liquids, sugar-based DAS, we synthesize DAS using a mixture of hydrogen bond acceptor, choline chloride, a quaternary ammonium salt, with several sugar-based hydrogen bond donor, such as glucose, fructose, sucrose, and xylitol at specific mole ratio. An amount of water was added to aid the reaction and was then removed before samples were sent for characterization. Okay, as we can see from here, these are the some striking physical properties of protic ionic liquid and DAS that we have been synthesized. The viscosity data for THS and sugar-based DAS. Okay. In terms of appearance, for example, THS resulted in white crystal solid, while for all DAS, we have got in a viscous clear liquids form. The synthesized product was sent to characterize using FTIR. As we can see, no appearance of amine bending peak from 1625 per centimeter to 1500 per centimeter, confirming the formation of tertiary amine salt. Okay, in addition, in contrast to tertiary amine salt, NH plus stretching with broad stretching were observed at a range of 2700 to 2500 per centimeter wave number. Okay, the other peaks observed represented the CN stretch, S double bond O stretch, and SO stretch at a wave number of 1234, 1153, and 1061 per centimeter respectively. Okay, for proton NMR, methyl and methylene proton peaks for THS appeared downfield as compared to the methyl and methylene proton in the triethylamine. Okay, this is due to the deshielding effect of positive charged nitrogen center owing to the protonation of triethylamine by HO in the sulfuric acid. Okay, this then confirmed the success of quaternization reaction lah. Okay, in carbon 13 NMR, it was observed that the methyl proton of THS shifted upfield as compared to the triethylamine, while no carbon shifting observed for methylene proton. This trend is related to the difference in electronegativity value between carbon and hydrogen. Okay, as we know that carbon is more electronegative than hydrogen, and as a result, a carbon atom that bonded to a number of hydrogen has very slight negative charge. As the methylene carbon attached to electronegative nitrogen atom, the methyl carbon appeared upfield due to the bigger electronegative effect. Okay, moving on, for glucose-based DAS, no appearance of new peak or disappearance of peaks in glucose-based DAS FTIR spectrum as compared to individual HbA, choline chloride, and HbD glucose in FTIR spectrum. Okay, appearance of wide and strong hydroxyl group peak at a range of 3,600 to 3,000 wave number in DAS spectrum. This proved that the presence of H bonding between HbA and HbD. Okay, the other peaks observed represented the methyl and methylene stretch, OH, OH band, CN, CO stretch at a wave number of 2,800 to 2,900, 1,600 to 1,300, and 1,050 wave number respectively. Okay. For proton NMR, no change in the proton chemical shift for choline cation, except for the hydroxyl, which shifted upfield in DAS spectrum. Okay, this possibly due to the increase in the ion pairing distance between chlorine, chloride, and ion with choline cation due to the H bonding formation between chloride anion and sugar hydroxyl group. Okay, appearance of several new peaks in proton NMR and carbon NMR for glucose DAS spectrum was due to the existence of the alpha glucose and the beta glucose anomers in the aqueous solution. All the glucose hydroxyl groups slightly shifted to D-shield region, possibly due to the interaction with chloride anion. Okay, moving on to fructose-based DAS. This appearance of carbonyl peak of fructose in fructose-based DAS indicated that the conversion of fructose open ring conformer to cyclic conformer. Okay, appearance of wide and strong hydroxyl group peak at a range of 3,600 to 3,000 wave number in DAS spectrum, proving the presence of H bonding between HbA and HbD. Okay, the other peaks observed represented the methyl and methylene stretch, OH band, CN and CO stretch at a wave number of 2,800 to 2,900 per centimeter, 1,300 per centimeter, and 1,300 per centimeter, and 1,050 per centimeter wave number respectively. Okay. Alright, no change in the proton chemical shift for choline cation except for the hydroxyl which shifted upfield in DAS spectrum. This is due to the increase in ion pairing distance between chloride anion with choline cation due to the H bonding formation between chloride anion and sugar hydroxyl group. Okay. Appearance of several new peaks in proton NMR and carbon 13 NMR for fructose DAS spectrum was due to the existence of the alpha fructose and beta fructose anomers in aqueous solution. Okay. All the fructose hydroxyl groups shifted to distill region, possibly due to the interaction with the chloride anion. Okay, so for sucrose-based DAS, no appearance of new peak, or as we can see the disappearance of peaks in sucrose-based DAS FTIR spectrum as compared to individual HBA choline chloride and HBD sucrose FTIR spectrum. Okay, appearance of wide and strong hydroxyl group peak at a range of 3,600 per centimeter to 3,000 per centimeter in DAS spectrum, proving the presence of H bonding between HBA and HBD. Okay, the other peaks that we can observe represented the methyl and methylene stretch, OH band, CN, and CO stretch at a wave number of 2,800 to 2,900, 1,600 to 1,300, and 1,050 wave number per respectively. Okay. So as we can see from the proton and carbon NMR, no change in the proton chemical shift for choline cation except for the hydroxyl, which shifted upfield in DAS spectrum. Okay, this might be due to the increase in ion pairing distance between a chloride anion with choline cation, again with the H bonding formation between chloride anion with the sugar hydroxyl group. Okay. And no chemical shift for proton and carbon observed besides the shifting of sucrose hydroxyl groups to distill region due to the interaction with the chloride anion again. Okay, H bonding formation. Okay, next is the xylitol-based DAS. Okay, as we can see, no appearance of new peak or disappearance again of peaks in xylitol-based DAS FTIR compared to the original HBA and HBD FTIR spectrum. Okay, so same as we mentioned before with the other sugar-based DAS, appearance of wide and strong hydroxyl group peak at the range of 3,600 to 3,000. In DAS spectrum, this proves that the presence of hydrogen bonding between HBA and HBD. Okay, and the other peaks observed are the same with the other sugar-based DAS that we have been synthesized before. All right. For proton and carbon NMR, no change in the proton chemical shift for choline cation, except for the hydroxyl, which shifted upfield in DAS spectrum. Okay, again due to the increase in the ion pairing distance between chlorine chloride and between the chloride anion with the choline cation. Okay, due to the hydrogen bonding formation. Okay. And no chemical shift for proton and carbon observed besides the shifting of xylitol hydroxyl group to distill region due to their interaction with chloride anion for H bonding formation. Okay, as for the conclusion, protic ionic liquid, triethylammonium hydrogen sulfate, and sugar-based DAS were successfully synthesized. Okay, confirmation of hydrogen bond formation between chloride anion of HBA, choline chloride, with hydroxyl group of sugar through FTIR and NMR were obtained.